I want to take a look at some of the examples that you'll come across now. This is in Khan Academy, analyzing and identifying proportional relationships. So let's take what we talked about with the table, the graph, and the equation, and we're simply looking to identify, is the relationship proportional, yes or no? It says consider the following equation. Y equals 7/2 or 7/2 times x. Is the relationship between x and y proportional? First of all, this is in the form of y equals a number times x. So my initial guess is, yeah, this is going to be proportional. To find out, fill in the table with the missing values. So let's go ahead and do this. Remember, x is my independent. X is allowed to be what it wants. Y is going to depend on the calculation of 2 times 7/2. So what you can do is take your calculator, paper, pencil. 2 is x, so I drag it up here and replace this x with a 2. So what is 7/2 times 2? The answer is 7. So I'm going to click here and type in 7. 4. 4 goes in for x. So this is now 7/2 times 4. Okay, the 4 is going to cross off with the 2. This will become a 1. This will become a 2. 2 times 7 is 14. The other idea in proportionality is this. My independent side is raising here by 2 every time. So my next one would be 6, then 8, then 10. If it's proportional, this side should be raising by the same amount. So it's raising by 7. 7, 14. Now graph the points listed in the table. Drag the points on the graph to the specified coordinates. So this is x is 2, y is 7. 2 in the x direction and up 7. 4, 14. Grab my other point, go to 4 in the x-axis, up 14. So I did my table, now my graph. Again, think back to what we discussed. Does my line go through 0, 0? And if it does, then it is proportional. So my graph proves that I am proportional. My table, it's rising by 7 every time, so this is proportional. And again, off to the side, I could do my calculation. I could do 14 minus 7, and I would get 7. I could do 4 minus 2 and get 2. That would be 7/2. And that would be my constant of proportionality. And guess what? 7/2 is the constant of proportionality in my equation. It's the same thing. So I'm going to go over here. Answer. Yes, the relationship is proportional. No, the relationship is not proportional. I'm going to pick yes. Check answer. Click. And it's right. So let's take a look at the next one. The following table lists the number of servings of spaghetti, whatever that is, that can be prepared with a given number of tomatoes. Is the relationship between the number of servings and the number of tomatoes needed to prepare them proportional? I'm going to click here, show scratch pad. Okay, now I can write. So now I'm using a table, so let's pick two numbers, 10 and 15, and that's going to be my top. I'm going to work bottom up, so that's 15 minus 10. And that's 5. I'm going to go this way, bottom up. I have to pick the same related numbers. 9 minus 6. 9 minus 6 is 3. So my constant of proportionality is 5/3. I have to pick two other numbers. The only other two numbers I can pick, well, there's different ways. I'm going to go down here. I'm going to pick 25 and 15. So there's 25 and 15. And if I do that on this side, then I must pick 15 and 9. 25 minus 15 is 10. 15 minus 9 is 6. It can reduce to 5/3. Are my constants equal? Are my results equal? The answer is yeah, it is equal. So that means if I go over and say answer, yes, the relationship is proportional, I should be able to click yes, and I'm right. This is the same kind of question. I'm going to try to skip through, get a different one. So it's a yes. Let's take a look at this next example. Now this one's a little bit different. Rectangle A's height is 5 centimeters and rectangle B's height is 12 centimeters. They both have the same width. So you can see here's rectangle A, height of 5, rectangle B, height of 12. They both have the same width. Consider the relationship between the perimeters. Now we're going distance around the outside of the two rectangles if their width changes. Is the relationship between the perimeters of the two rectangles proportional? Fill in the table. Perimeter of rectangle A. So we're dealing with just rectangle A. If the width is 1, so that means this is 1, this is 1. So what's my perimeter around? Well, this is 5, this is 5, this is 1, this is 1. 5 plus 5 is 10, 11, 12. That's 12. Perimeter of rectangle A if the width is 2. 5, 2, 5, 2. 5 plus 5 is 10, 11, 12, 13, 14. So that is 14. Now let's look at rectangle B. Perimeter of rectangle B if the width is 1. 12, 1, 12, 1. 12 plus 12 is 24, 25, 26. Width of 2, 12, 2, 12, 2. 24, 12 plus 12, 24, 25, 26, 27, 28. So I'm going to use my scratch pad, and what I have here is 3 columns, so it's a little different than the table we looked at before. What I want to show you is this. It's asking the perimeters, the relationship between perimeters. What I can do is actually take these two, my perimeter from rectangle A, rectangle B, they're related because they both had the same width of 1. And what I can do is make a ratio out of these two. So that's 12 to 26. And I can reduce that down and I can get 6/13. So the other part of this is I can always make a ratio out of these things at really any point. Here's 12/26. So that means my constant of proportionality is 6/13. If these are going to be proportional, that means this has to have the same constant of proportionality as well. So I can take 14/28. I can divide both by 14 and I get 1/2. Now when I look at these, are they equal? The answer is they're not equal. So that means they are not proportional. I did not end up with the same constant of proportionality, the same rate of change, so to speak. So I can click no, and that one's correct. So let's take a look at the next one. This is the same exact question. Here's my rectangle A, which is with height of 5, rectangle B. Do you notice what's different though? I didn't. I actually tried this and I got it wrong because I didn't read the question. It's now talking about the areas of the two. So this is area. Rectangle A, height of 5, width of 1, 5, 1. Those are the only two numbers I need because area is length times width. 5 times 1 is 5. 5 and a width of 2, that's 10. Let's go to triangle B. 12 and 1. 12 times 1 is 12. 12 and 2, that's going to be 24. So remember, what I can do is take each one of these as separate proportions. This would be 5 over 12. Can I reduce? I cannot, so that's 5 over 12. This is 10 over 24. I can reduce, divide both by 2, I get 5 over 12. And guess what? I have the same constant of proportionality, they are equal. So my answer will be yes. And I got it right.